everyone, it's Mrs. Summer here to talk about the Unit 5 gas laws review. So the first problem was count the number of atoms for the following molecules. So the first one has 6 sodiums, 6 oxygens, and 6 hydrogens. The part B is there's 12 calciums because you do 4 times 3, which is 12. For phosphorus, there's 2 times 1, which is 2, times another 4 is 8. For oxygen, it's 2 times 3, which is 6, times the 4 on the outside, 24. The next question says, identify the subscripts and coefficients from 1b. Explain the difference in their meaning. So the subscripts are the 3, 3, and 2. So they are this one, and this one. After the element symbol, it tells you how many of each atom there are. The 4 on the outside of the whole molecule tells you how many molecules there are. The next question says to balance the following equation. I've labeled my reactants as my Al and HCl. This is my yield sign right here. And then the products are the AlCl3 and H2. Now to balance it is 2Al plus 6HCl yields 2AlCl3 plus 3H2O. This next question goes over to 2 slides, but it says define kinetic molecular theory and its components. So the first component is gas particles do not attract or repel each other. The next part of kinetic molecular theory is that gas particles are smaller than the space between them, and almost all of the volume of gas is empty space. That gas particles, or atoms or molecules, are in constant motion. That no kinetic energy is lost when the particles collide. And that all gases have the same average kinetic energy at a given temperature. So those are the components of kinetic molecular theory. The next part says to convert the following temperatures to Kelvin. So 23 degrees Celsius, I add 273 and I get 300 K. The next one is 36 degrees Celsius, I add that to 273 and I get 309 K. The final one is negative 12 degrees Celsius. Well, 273 plus negative 12 is 261 K. This next question says, identify the variables and the units that we're using in gas laws. So T, which is temperature, and we're using Kelvin. P is pressure, and we're using the ATM, the atmosphere. V is volume, and we're using the liter. The next question is about Boyle's law. Explain the relationship between pressure and volume. When one goes up, the other goes down. This is called inversely proportional. So what is the equation for Boyle's law? It's P initial, V initial equals P final, V final. So P times V equals P times V. You'll often hear me usually say is P1 V1 is equal to P2 V2. Kind of means the same thing. Rolls off the tongue a little bit easier, but it essentially means the same thing. What you start with times what you start with equals what you end up with times what you end up with. So this question is about Boyle's law. It says solve the following. A gas tank holds 2,785 liters of propane at 1.09 ATM. What is the volume of the propane at standard pressure? So 1 ATM. So if I draw my box, my table, my initial pressure was 1.09 ATM. My initial volume was 2,785 liters. My final pressure was 1 ATM. And my final volume, we don't know, so I'm going to label it as X. And the change is the pressure decreased, so the volume must have increased. And so my PI VI equals PF BF. If I plug in those numbers, I get 1.09 times 2,785 equals 1 ATM times X number of liters. If I do that math on my calculator, I get 3035.65 ATMs times liters equals 1 ATM over liters. And so when we divide, my ATMs cancel because I'm going to divide both sides by 1 ATM. My next question is, a balloon contains 7.2 liters of helium. The pressure is 2 atm and the balloon expands to occupy a volume of 25.1 liters. What is the final pressure in the balloon? So my table looks like this. My initial pressure is 2. My initial volume is 7.2. My pressure or my volume increased to 25.1, which means my pressure must have decreased. When I set up the math, I end up with PIVI equals PFVF. I end up with 2 times 7.2 equals X number of ATMs times 25.1 liters. 2 times 7.2 is 14.4 equals that. And then I'm going to divide both sides. So I'm going to end up dividing 25.1. And when I do that, my ATMs cancel. And I'm left, or I'm sorry, not my ATMs. My liters cancel. And I'm left with 0.574 ATM. This next part discusses Charles' law and explain the relationship between volume and temperature. When one goes up, the other goes up. This is called directly proportional. And the equation for Charles' law is VI divided by TI equals VF over TF, or V1 over T1 equals V2 over T2. This question says, solve the following. An experimental research tank with a volume of 15,000 liters has a temperature of 75 K. The temperature of the tank increases to 300 K. What will the volume of the tank be? So I set up my table with my initial volume, my final, I don't know what my final volume is, my initial temperature, and my final temperature. My temperature increased, which means my volume must have increased. When I plug that information into the formulas, I am left with 15,000 over 75 is equal to some number of liters over 300 K. And you have to cross multiply to solve for your unknown. So I'm left with 15,000 times 300 is equal to 75 times something we don't know. So 15,000 times 3,000 is 4,500,000 divided by 75,000, divided by 75, and we are left with 60,000 liters. This next question states that a basketball was left outside overnight. If the volume of the ball was 2 liters when it was 310 K outside, what's the temperature in the morning if the volume of the ball was 0.5 liters? So I have my initial volume, my initial temperature, my final volume, and my final temperature. So my volume decreased, so my temperature must have decreased. If I plug those into the formula, I get 2 over 310 equals 0.5 over X number of Kelvin. Cross multiply, I get 2L times some number of Kelvin equals 310 times 0.5. 2 times some unknown equals 150. And then solving for that unknown, I get 155 over 2. My liters cancel, and my answer is 77.5 K. This next section talks about the ideal gas law. So define, describe, and write the units for each of the variables. So P is pressure in ATM, V is liter in volume, N is mole, and it's the quantity of the gas that we have. R is your gas constant. Its unit is liters times ATM divided by mole Kelvin. And your temperature is in Kelvin. And then this next question is, what is STP? So standard temperature and pressure. It's 1 ATM and 270 K. So this next question is, and let me see, I gotta zoom out, is a container holds 500 liters of CO2 at 20 degrees Celsius and 0.98 ATM. How many moles of CO2 are in the container? So note you first have to convert 20 degrees Celsius to K. So my pressure is this, my volume is here, N is what we don't know, R never changes, and then T is 273 plus 20 equals 293 K. Plugging those into the ideal gas formula, which is PV equals nRT, and then rearranging the equation to solve for N, so N is equal to PV over RT, I'm left with N is equal to 0.98 times 500 divided by the quantity of 0.08206 times 293. Remember, if you're doing this in the calculator, you need to put it in parentheses like this for you to get the correct answer. A lot of times when you're not getting the same answer I got, it's most likely an user input to calculator error. If you set it up all right on paper, just didn't get the right answer. So N is equal to 20.4 moles of CO2. This last question says a gas tank holds 2,785 moles of propane at 273 K. What is the volume of propane at standard pressure? So on your paper, it might say that this is 273 liters. I've corrected that for the key. So just change that to 2,785 moles of propane. So I input into my table 1 ATM. Volume is what we don't know this time. N is 2,785 moles. R doesn't change. And T is 273 K. My equation is PV equals nRT, so PivNert. V, rearranging to solve for the variable I want. V is equal to nRT divided by P. V is equal to 2785 times 0.08206 times 273 divided by 1. So the final volume, or the volume of the gas, is 62,390.6 liters. Please let me know if you have any remaining questions regarding Unit 5 concepts. Also remember that your Unit 5, all Unit 5 work is due with mastery by the day of the unit test, which is Thursday, 1/14 for period 5. All your Unit 5 work is due by Thursday with mastery, so 90% or higher, in order to earn credit for the work. I will not accept Unit 5 work after Thursday's date.